Hello, Wim Dijkgraaf here, Metal Heaven. Here a video with the basic explanation of our native JSON file format. It's not a file format, but actually the JSON content and how to work with it. So I'll explain in this video how that JSON is constructed, when it is created, how to obtain it. And that JSON is our proprietary format to build integrations, for example, with your own ERP system or with your CAM systems. First of all, a couple of resources on the internet that are valuable for developers. First of all, if you go to GitHub, you find the Rhodium24 repository. You will find actually 4 categories here, but the most important repo to start with if you want to build your own integration is the Rhodium24 Basic Integration Quick Start. That's this. It's an executable that listens to incoming commands or content on the file system using a built-in file watcher. It picks up automatically the JSON file, does do the whole deserialization, such that within C# or any .NET language like F#, you immediately have the whole project structure as an object model available. So please check out this if you want to integrate with a Rhodium behind the Rhodium agent. That's one. The second one is if you want to do it all on your own, then on NuGet, the Metal Heaven external data contracts are critical. You see that regularly we publish new versions. The JSON is completely based on these external data contracts. So it's important that you use this NuGet package and that you update this NuGet package frequently. Then what you will find in this external data contracts are various properties of classes which are based on, for example, the UnitsNet library. So all the unit specific properties of classes, we made those units of measure explicit using the UnitsNet library. So here you see all kind of information about length, about masses, about speeds, etc., durations, and that's what you will find all over the place in the JSON file. So that's based on UnitsNet. Then the last library we use extensively is the Noda money library. Noda money includes all the explicit currencies. So also where we use money, we use the Noda money library to make currencies explicit. In the backend, by the way, we use our own version of Noda money, which doesn't do any rounding. So be aware that the Noda money library itself, by convention or by design, does do rounding. For some applications or use cases that is what you want, for others it's not. So we created our own version of Noda money which internally doesn't do rounding, but what you will see in JSON, in the JSON file can be read using Noda money without any problems. So those are the most important 4 resources. Now let me switch to Rhodium and show you how to easily obtain the JSON file with all the details about all the project details. Let's make this. So I uploaded a simple assembly with a purchasing part, a sheet metal part and another sheet metal part. Create a formal quotation. by simply assigning material over here and apply it. Let's have a look at the nesting. So we see remnant pieces here. So the quotation was created, and let's have a look at the JSON file that we now have. So I press download, open the zip file, and here I dragged and dropped the JSON file in Notepad++. I use a plugin, the Json Viewer, format JSON, so now we have a viewer to have a look at the content of this. Let me close everything. Okay, so what you see is a JSON file with all the types explicitly defined in the JSON file. So you see versioned, external data contracts, project version 1. From the namespace metal have an external data contracts, and this refers exactly to the NuGet package. So this NuGet package over here. And that's something that we do for all the elements in this JSON file. So all the properties which are complex data types, those types are made explicit. Okay, so what do we see here? Here you see the project itself. So the project reference is JSON tutorial. That is what we see here, JSON tutorial. The order number is 1. That is what we see there. This is the internal ID of this project. And we see here properties like labor, recognized labor, features, financial, inherited from a data type called BOM item. So if we look at the C# code and we go to a class named BOM item, it's BOM item v1, then we see that it implements a couple of interfaces. Those interfaces are not relevant if you use the JSON itself. But you see here an ID, the labor, the recognized labor, features, financial, estimations, machining, and manufacturability results. If we now have a look again at the JSON file, then you see manufacturability results. Let's put it like this. Manufacturability results, machining, estimations, financial, features, recognized labor. Yeah, so that is all inherited from the base class BOM item v1. Okay, why is this relevant? Because the project is a BOM item, the assemblies and subassemblies are BOM items, and the parts are BOM items. So if you open up BOM now, which is the whole BOM structure, the bill of materials structure, then you will see items here that are inherited from are inherited from the BOM item. So for example, let's have a look at part list. We would expect 3 parts here. You see 3 parts because the assembly that I uploaded has 3 parts. If you look over here, then you will recognize the same kind of properties like manufacturability results, machining, estimations, financial features, recognized labor, ID. So this is all inherited from the BOM item itself. So in the part list are part types, actually, that's how we call it. You see that over here, a part type. More explanation about that later. And this is a BOM item. These are all BOM items. Then if you look at assemblies, then here you see a tree structure with assemblies and sub-assemblies. Let's again have a look at it. Again, the main assembly is a BOM item itself, so you see those properties again: manufacturability, machining, estimations, financial, recognized labor, up to the ID of the item here. So this is all inherited from BOM item. If you look at sub-assemblies, then again you see here a sub-assembly, and again all those same properties appear. So it looks like a lot, but it is more of the same, because it's all based on BOM items. Okay, now let's go back to part list. What's the meaning of the properties that you see here? Of course, it's a part type. What is a part type? A part type you can is kind of similar to a BOM line item, and a BOM line item then is an individual part to be manufactured. Okay, so row number is the row number that this row number represents a row number over here, which is 1, the name, this JUS to, what is it, 20,000, 200,006, the original file name, so that's the file name of the main assembly in this case. We see a quantity of 4, and now you see probably that this refers to 4 part instances. So this element appears in the whole assembly structure 4 times, and this refers to all those instances of this specific part type in the assembly structure. And of course those part instances you will find later in the assembly structure here, such that you know exactly where in the whole assembly and sub-assembly structure these part instances are applied. Then material. Yep. So what do we see here? We see a class named selectable articles, and it has a selected article. By the way, what you also see here, selected keywords, sheet 4mm thickness steel S235. That's exactly what you see here as being the keywords. Then the actually article that has been selected, you see here. So this is the article number and this is the article description. And here again you see the keywords or tokens that this selection is based on. Then you see all the recognized properties, dimension-wise, of this specific article. So you see the area, the thickness of the plate, the length and the width. Here you see the units of measure, so we use millimeters, 3000 millimeters. These are dimensions. Here you see the weight of this, so that's the calculated weight of one such a plate in kilograms, so that's the mass unit. Then you see also purchasing data, so based on the article file that has been uploaded, you see an amount in euro, which is a money type, and here you see a quantity. This means that for this price is defined as the price for 1 kilogram. You could also say this is the price for 6 meters, or for example this is the price for 4 square meters. So all kind of combinations are possible. So it's a money per quantity. That's the purchasing price. And then we calculate, this is how you purchase it. Then we calculate a price per mass. So here you see for 1 kilo the price will be this. So even if under gross price it would have been specified in length, then you still would see here a calculation of the price per kilogram. And then here you see a gross price per item, so per sheet in this example. So that is the selected article. Then what we see here is the financial, and this is important because this is calculated or estimated. And financial is really a critical concept. It has all the financial data for the price for one item, the sales price, the applied surcharges, etc. So what do we see here? We see a total project quantity of 1 and we see a quantity of 1. That is the one that you see here. So this is the total project quantity and this is the quantity of the item itself. So that's the difference between total project quantity and quantity. Then items, you see here sometimes item and items. Items relates to the total project quantity and item refers to one item. So what do we see here? We see a cost price per item of 18 euro and we see a sales price per item of 23 euro. And the difference between this is the discount or surcharge. This can be, of course, a negative value, then it will be a discount. A positive value, then it will be a surcharge. So that has been calculated as 5.42. So 18 plus 5 is 23. So that's at item level what happens here. And then you see the same, the discount for all the items is this, and the sales price of all the items is this. And since it has a quantity or a project quantity of 1, these numbers are the same. This financial you will see all over the place. So also, for example, for calculating the costs of working steps. So back to the material financial calculation details. This is the explanation that you also see in the user interface if you press here. So you see the sum of 2, 3, 4, 18.08. That's exactly what you see over here. And then here the used ratio per item. That's also an interesting property. So based on the nesting settings and the remnant behavior, you see here that this has a decimal fraction of 0.076 blah blah blah, which represent the amount of material that this part uses based on the nesting results. So the 0.07, what you see here, and that is based here on this remnant calculation. So this piece should be 7% of the whole. Okay, that's material. Then here you see a base 64 representation of the thumbnail. So that in this case is the 3D. You see a 3D and a 2D thumbnail. This is the 3D thumbnail. This is a 2D thumbnail. So these are the base 64 representations of those thumbnails in PNG format. Then nesting direction, that is what you see here. So whether it's free or X or Y. So that can be found here in nesting direction. This is the ID of this part type. So every BOM item has a GUID as an ID. Then we see here labor 1 and 3. Let's first go to recognized labor, which is the same, 1 and 3. So when the recognition engine has done its work, it probably has found working steps based on this geometry, and what it has recognized is represented here. And these are enumerators. So if we go again to the NuGet package, then what we will find here is an enumerator working step type. And what it has found is 1 and 3. 1 is sheet cutting, 3 is sheet bending. So that's what this represents. Then there is a difference between recognized labor and labor. Labor is all the labor, including the manually added labor. So if you press this button and you add working steps here, then those working steps will show up in labor and not in recognized labor. Then we have something like features, and let's have a look at, let's first have a look at measurements. So what do we see here? Let's first have a look at thickness. Again, length unit millimeter 4, and that's exactly what you see here. A sheet of 4 millimeter with a thickness of 4 millimeter. That's thickness. Then we see areas and volume. So we see here a bounding box of 6, also in millimeters, 693, and that's what you see here, 693.94. So that's the length, the width, and the height. And also the volume. This is of course the volume of the bounding box, and that's not what we show here. So this is the volume of the 3D bounding box. Then we have the same kind of properties for the 2D bounding box. Oh, these are square millimeters. Okay, so this is the area of the outer contour. So we see that over here, the 2.7, that's the 2.7 here. We see the area of the holes inside here. So that's this one, and that is this one, but it's rounded. The net area of 265, which is the net area here. So these properties can all be found here in the JSON. And here the volume information in cubic centimeters, which you find here. So all the details are also in the JSON. Contour-wise, you see a whole list here, and that represent the contours over here. So probably 16 elements here, and the 2258 is the 2258 here, and the 340 is the 340 here. So here all the contour lengths can be found. Well, you will have to dive into the details and do a matching with what you see in the user interface, but you will find that all the geometric cost drivers will be found under features. Then let's have a look at financial. In order to have a look at the financial, let's make this a little bit smaller and move to over here. So what we see here in the user interface is the 3869, which you see here, 3869. That's the sales price per item. If we open this and we grab the JSON here, should become clear that the 2946 that you find here, which is the total cost of all these aspects, 2946 you find here, the 29456. The percentage is of course a calculation, a calculated value, and then the 3869 can be found, the 3869 can be found here, and 31.34% of a surcharge can be found here as a decimal fraction. So the totals of these are a financial that can be found as a property of the part. Then all the estimations done. And what you see here is that the estimations collection is grouped in two parts. And that is because we see sheet cutting and bending over here. And sheet cutting estimations are grouped in 3 activities, and bending is grouped in 3 activities. So if we look here, then we see consists of a pair, a primary and a secondary working step. The primary here is 1, which means sheet cutting. And the secondary is 32, which means loading. So here we see the estimation results for sheet cutting loading. If you look at production time, then here you see the estimated time for this in seconds for the sheet cutting loading. If we go to the user interface, then we see sheet cutting loading estimated for 1 minute. And that's exactly what we also see in the JSON, 60 seconds. Then we also see additional costs at 0. That is correct because here we also see 0. Then the rate is €45 per hour. That's what we see over here in the UI, 45 per hour. That's the rate. The external code is the code used for your ERP system that you have configured. And let's have a look at the financial. So what do we see here? The cost price of items, 75 euro cents. We see a percentage of 30, which represents this. We see a 225 euro for the discount or surcharge, which represents this value over here. And here we see the sales price of items, the 975, which we see over here in a rounded fashion. So all these details in this table can be found in the JSON as being working step estimations. So probably this is the main information that you need in order to understand the structure, as well as the where to find the various prices and estimations, as well as features found by Rhodium. I hope this video is helpful. Please let me know if there are critical things that we missed in this first video. And I wish you a lot of success implementing your own integrations. Have a nice day. Bye bye.